Lenz law. Lenz law is convention alternative method for determining the direction of an induced EMF or current. The demonstrate the Lenz law consider the south pole of the magnetic toward the coil as shown in figure. As the south pole of the magnetic moves toward the coil, the magnetic flux the coil increase. Let us consider a conducting rod placing in the horizontal magnetic field as shown in figure. Both end to the rod is connected. That we have the Lenz law of state of magnetic field if the force is greater than the magnetic flux. Then the magnetic flux is forced to the state of ionotic states. If the ionotic state is provided by a EMF induced, then how we show to provide an extra potential energy to the centripetal force of the Lenz law that we have not more to provide in the lens of each together. Faraday's law of electromagnetic induction states that the practical demonstration of electric magnetic induction is previous article moved to EMF induced in a coil depend upon the following factor. EMF is directly proportional to the rate of exchange of magnetic flux. Greater the rate of change in magnetic flux through the coil, greater is induced EMF. 2. EMF is directly proportional to the number of turns n in the coil. Greater the number of turns, greater is induced EMF. The equation for the EMF induced is induced EMF where K is constant and the value of K is equal to 1. Above equation is called Faraday's law of induction. The induced EMF always opposed to the following state of Lenz law. If the corresponding force, centripetal force, is provided to the state of energy, it is equal to the generates of dates length 7.13 m. So the Lenz is equation convinced alternative method for determining the direction of providing a state of magnetic toward the coil as shown in figure. The coil resembled the south pole and repeated its north pole. That how much it considered the induced current will oppose the charge and change of flux that it created it. On the other hand, if the south pole of the magnet is moved away from the coil as shown in figure, the magnetic flux linked the coil decrease. The coil resembles its north pole and attracts the magnetic when it is pulled away. The direction of the induced current EMF is such that its own magnetic field, the direction and the way to compose the changing flux caused by the magnetic field to the approaching magnet. The direction of the induced current can be determined by applying right hand rules. Please stop on 7.15 minutes, okay? 7 minutes 15 seconds. Similarly, when the north pole of the magnetic is moved toward or any from the coil, the repulsion and attraction take place between the coil and the moving magnet. The always opposed to motion of the state is energy. So the equation is become the Lenz law and constant of energy. Lenz's law is a conversing in law of conservation of energy. In previous example, when the end pole of the magnet is approaching the coil, the repulsion force acts on the bar magnet due to the current induced in the coil. The result is that the motion of the magnet is opposed. The mechanical energy spent in overcoming the opposing is converted into electrical energy, which appears in the coil. Thus, Lenz's law is consistent with the law of conservation of energy, at which rate would it be energy is necessary for a single conductor to cut the flux in order that a current of 1.2 mA flow. Current it was 10 theta time resistance is connected across its end. The constant of Lenz's law is consistent with the law of conservation of energy. A coil of mean area 1500 centimeters square and having 1000 turns is held perpendicular to the uniform field of zero point 0.4 Gauss. The coil is turned through 180 in 1/10. Calculate the average induced EMF. The result is that the motion of the magnet is opposed. The mechanical energy spent in overcoming this opposition is converted into electrical energy, which appears in the coil. The Lenz law is consistent with the law of conversion of energy.